rational number. So first, let's look at this one here is 9.5. So we need to understand what is a rational number, what's an irrational number. Every single rational number can be expressed in terms of fraction. Okay. So all fractions are rational numbers. So if you can write it in terms of fraction, or you type in your calculator, you can change it to a fraction, then it is considered to be a rational number. Like 1/3, 1/8, 5/2, all these are considered to be rational number. However, there's something called terminating decimals, meaning that for rational numbers, you will see numbers that it stops, it terminates until a certain number, it stops. So that's what we call terminating numbers or terminating decimals. But for some, they recur. Recur means that continuously repeat itself. As you can see here, this tree, it repeats itself, and they put ... means it will never end, ever. So sometimes we need to find out from the recurring decimal, how do I change it back to a fraction? So recurring decimals are written this way. If it is 0.3333 and it never ends, it is written like this, 0.3 with a dot on top. So it means that only the number 3 will be repeated. If it is two numbers repeating, 0.454545, then 2 dots will be placed here. However, if it is 3 numbers that repeats itself, 302, 302, 302, and it continues, there will not be 3 dots, but there will be 2 dots. One in the first number, second dot on the last number. Then you can see this is a recurring decimal of 302, 302. For example, if I write recurring decimal of 4 numbers, 4, 1, 2, 3, 4, 1, 2, 3. I will put it as 0.4123 ... 1 dot on top of 3, 1 dot on top of 4. That means that 4123 will repeat again and again and again and again. So now what we need to learn here is to convert recurring decimals into fractions, because that is what we are going to do below. So first, let's look at an easy one, 0.4. Okay, do not memorize the numbers, because some numbers, as you see, eventually it is the same. So for example, 0.4 is always 4/9. So it is easy, but you need to show your working. So that's the tricky part. So in the beginning, we are going to let x be equal to 0.4 and the dot on top of 4. So 0.444444. So I'm just going to write it out like this. So x is equals to 0.444444. So in my opinion, I'll just show it on the right hand side here. I normally put only 4 decimals, depending on how many times it repeats. So if it repeats 1 time means 0.444, I just put 4. If it repeats 2 times, I'll just put 4 as well. If it repeats 3 times, I'll put 6. Means 6 decimal places. So here, if it is 0.4444, I'll just put it this way. So x is equal to this. So let's put, I want to remove the recurrence. Removing recurrence means that I don't want it to repeat anymore. So as you can see, it repeats 1 number, so I'll just multiply it by 10. I will then move the decimal place in front. I will still put 4 decimal places. As you can see, they have a common thing here now. These two are common. So if I take 10x minus x, this whole thing will be removed. So 10x minus x, I will get 4. And then 10x minus x is actually equals to 9x. X is equals to 4/9. So there you go. I managed to remove the recurrence and find out the fraction. So this is the easy one. After this, we're going to look at the more difficult one, where they have more than 1 decimal place that is recurring. So the first one, this one is easy. We're done already. So as you can see, I'm just multiplying by 10 because it is only one recurrence. One number repeats itself. However, let's look at the second one here. There are two numbers that are recurring. So what do? We multiply by 100 this time because I want the repeating number to show. So you can see it shows here. If I multiply by 10, I couldn't solve it. So for example, if x is equals to 0.2424, 10x is equals to 2.4242. You can see the recurrence cannot be removed because they do not have anything in common. I cannot do anything here because everything is, there's nothing in common. I cannot take 10x minus x. So if I put it to 100x, however, then there is a recurrence. You can move the decimal place here. 24.2424. So you can see now there is a common here. Then I can just minus them away and remove the recurrence. So I'll get 100x minus x is equal to 24. 99x is equal to 24. X is equal to 24 over 99. Okay, this one, if it's three numbers that are recurring, then it's 1,000. So if it's four number, then it's 10,000 and so on. So this one is just depending on how many numbers it's repeating. But I want you to look at this one here, for D. D, the book doesn't teach you based on logic. So I don't really like what's happening here. So what I would do is I will actually split the decimal. So follow me for a bit. Here, let's look at this one here. I'll just do it on this side. So the question is 0.524 recurring only one decimal. So the x, you cannot write x actually. I don't want to write x, that's not to say cannot. So it is actually 0.5244444. So it's actually a combination, so I don't really like combination. So what I would do is I would split the fraction into two. So recurrence is once. So one number that is recurring, so I need to multiply by 10. So instead of letting the whole thing equals to x, I only let this equals to x. Like I said, I repeat the number 4 times. I'm just going to do it again. So 10x I'm going to write the same amount of decimal places so that I can remove the recurrence here. So I'm just going to remove 10x minus x. I will get 9x is equals to, removing the recurrence, I get 0.04. So x is equals to 0.04 over 9. Change it to a proper fraction. For the top, I multiply by 100. The bottom, I also multiply by 100. I get 4 over 900. So go back to the beginning. I still have one more fraction left. So I'm just going to add these two together. 52 over 100 plus 4 over 900. And I'll get my answer here. Press in your calculator. You should be able to get your answer. I prefer it this way. If you don't like this way, you can actually follow what the book teaches you. But book ones don't really like it.